postman mana, let me inform them. Okay, because this time I tried to open the camps, enter, nothing appeared.
Yeah.
Okay, so next week. Okay, so let's start our lesson. Okay, we supposed to do, yeah. Can see the slide? Can,
Yes.
Yes, give a minute. Sorry, I forgot the pen. Hold on. Okay. So today we're going to do about modulation, FM, AM. Last week we did what? Last class we did about how the signal is channel sent through by which channels: wire pass, coaxial cable, optic fibers, radio wave, and microwave. Okay. So today we talk about why we need to do modulation. Okay. Okay. So let's start. Okay. So you see this picture. You are the transmitter. You are talking to your friend, and your friend is a receiver. It's a short distance. When the technology improved, we tried to bring our conversation a long distance. So this is about like a microphone connected to wire microphone to the loudspeaker. So be able to communicate from the other room, long distance, but not very long, maybe few less than 100 meter. Okay, then what happened? The microphone become wireless. Okay, we talk, and the sound was changed to electrical signal. Electrical signal is sent through aerial in the air and received by your friend, loudspeaker. The electrical signal captured, changed to sound. Okay, so this is like the walkie-talkie. So in all communication, there is a transmitter and receiver. Everyone is to send out their information signal through the antenna as they are, and all the receive is just noise and no information. Just you see, the third step only can be done by only one conversation. You see, the human can produce a sound. The sound it can sense 20 to 20,000 hertz, right? 20 to 20,000 hertz. So let's say the first communication, this guy will make a frequency of, let's say, 1,000 in this range. Okay. So let's say another this is A to B, A talking to B. In let's say in Taylor's, okay, in Taylor's, A talking to B by using this method, and C and D also in Taylor's, they want to talk. C want to talk to D by using the wireless method. But C also is a human. He also going to produce the frequency, same range, 20 to 20,000 hertz. So when the A to B and C to D, these two signals transmitted in the same region, what happened? Interference happened. Okay, when the B get the signal, the both signal will enter into B, and the both signal also will enter into the D device. So what happened? At the end, what you're going to see is the two conversation at the same time is listened by the B. It's apparently it's going to be like a noise. Okay, it's a noise. So let's say you want to use this communication, but let's say you want 1,000 people want to communicate at the same region, or it's going to be a massive noise. Why the noise happen? Why interference happen? Because all of them have about the same frequency, 20,000 hertz. Because all human produce this much of frequencies, so interference will happen because of the same frequency. So you want to go for the third method. So how are you going to avoid they are interfered at the same time? All the 1,000 communication goes at the same time, like what happened now. Okay, your friend can receive a call, and you can receive a call at the same time in the classroom. Okay, let's say you are 20, 30 of you in a classroom. 30 of you can receive the call at the same time without no interference. Okay, because why? Because the frequency the signal received by your friend and you, the frequency is different. Okay, why the frequency is different? Because we never allow the sound to travel, the electrical signal of the sound, but we allow the radio wave to act as a carrier. The radio wave carry the signal. Okay, so let the radio wave carry the signal. Okay, and why we use radio wave? Because radio wave have two advantages. One is what? Move with speed of light very fast. Second is what? Carrier wave. Radio wave has a range of frequency, a huge range of frequency where everyone can given a different frequency, so that never interfere. Okay, that's the main reason why we went for a carrier wave. A carrier wave. So when a person talking to a microphone is not directly to send to the aerial. Before you send to the aerial, his sound will be modulated with the carrier wave, a radio wave, and that radio wave will be transmitted. Okay. So let's go in depth how the modulation is done. So technology decided that we let the radio wave to carry out the information signal and assign a different radio wave band to transmit various information. Hence, they send to our receiver the amplitude modulated and the frequency modulated signals, AM and FM. So AM, FM modulation. The signals that we receive are either amplitude modulated or frequency modulated. I told you a little briefing about this earlier. AM, FM is better than AM in terms of quality. Let's go in depth today. Okay. So what is modulation? Modulation is the process of one signal is added onto another carrier signal. Okay. So in exam, they'll give two waves. You should know which wave is carrier. Which wave is carrier? The one with the smaller period is the carrier. Because radio wave has high frequency. Then sound what? Sound is 20 to 20,000 hertz. Radio wave is what is the radio wave frequency in megahertz, right? Radio, you open your you switch on your radio. The radio will say what? This hot FM or something is had in 78.4 megahertz. It will be in megahertz. So sound wave is only in what? Only in kilohertz, right? 20,000 hertz only, kilohertz. So, and the two signals given, you should know the one with the high frequency is the carrier, the one with the low frequency is the signal. Remember, high frequency is the carrier, low frequency is signal, radio wave. The carrier wave has a much higher frequency than the information signal, remember. The carrier normally will follow the x equals to x naught sine omega t pattern as sinusoidal. Okay, the amplitude and the frequency. Okay. Okay, now what will happen? Let's say this carrier has a 5 volt of height and this signal has a 2 volt of height. What happened? This carrier will be added on top of that. Until the signal up here become 7 volt, here can go drop by 5 minus 2 because here 2 here negative 2. 5 minus 2 is become 3 volt. So it becomes 7 volt, 3 volt. 7 volt, 3 volt. So the pattern will change to like this. Say it become like 7 volt. Here the lowest will become 3 volt. Okay, if the signal has a 2 volt of amplitude, just added on top of it, So this is called amplitude modulation. Okay, so please remember this, very important. They will ask in exam. Many times they ask, what is meant by amplitude modulation? Amplitude of the carrier wave. The amplitude of the carrier wave is vary in synchrony with the displacement of the information signal. Okay, the carrier wave amplitude was changed in synchrony with the amplitude of the information signal, displacement of the information signal, just embedded. It's called amplitude modulation. Very important. Please memorize this definition, 2 marks. Okay. The amplitude of modulation, amplitude of the carrier wave. Don't say amplitude of the signal wave. The The amplitude of the carrier wave is made to vary in synchrony, keyword synchrony, according to the pattern, the displacement of the information signal. Okay. Okay, frequency modulation. The frequency going to be altered. The same wording, everything same, but except frequency of the carrier wave is made to vary in synchrony with the displacement of the information signal. Let's say this is 2 volt, and this is 2 volt, this negative 2 volt. Originally, the frequency is at 0 volt, at 0 volt. At this point where the original frequency, let's say, is 500. I put let's say megahertz. Okay, megahertz, 500 megahertz. Okay, when the amplitude get high to 2 volt, okay, the frequency increases. How much you're going to increase? Depend how do you modulate it. Normally they give a scale. Maybe they will say, okay, for every 1 volt, 50 megahertz will increase. Okay, 50 megahertz per volt. It's a scale to follow. There is a scale, they'll tell you. So the signal, the carrier change frequency 50 megahertz per volt. That means here the amplitude become how many volt? Become 2 volt, right? So the frequency going to increase by, originally was 500. Now when the 2 volt rise to 2 volt, it becomes 600 megahertz. The frequency increased by 600. Yeah. At the negative 2, the frequency drop by but every volt is 50 megahertz. So negative 2 means 100. So 500 become 400. It become 400 megahertz. So frequency going to vary accordingly. And peak frequency is high, and trough frequency is low. This is all frequency modulation. Any questions? Okay, we will do the examples, then you get better idea. Okay, one example. So a sinusoidal carrier wave has a frequency of 800 Hz. This is a carrier radio. It's 800 kilohertz. Okay, so carrier, the one more with the lots of frequency. 800 kilohertz. Okay. I see here the reading. Frequency deviation of the carrier wave is 30 kilohertz per volt. When they give this value, you should know it's FM or AM. 30 kilohertz per volt. They say the frequency going to deviate by 30 kilohertz for every volt. Therefore, this is FM or AM. It's your FM. Frequency is changing. When you see kilohertz per volt, that means it's a FM. Okay. That is for every 1 volt change in displacement of the signal, the frequency modulated by the frequency signal frequency display. That is for every 1 volt change in the displacement of the signal, the frequency modulated by the signal frequency 10 kilohertz. So every 1 volt 30 kilohertz frequency will change. The frequency modulated by the sinusoidal signal is this. This is the signal frequency, signal amplitude. Okay, 2 volt is what? 2 volt is the signal amplitude. 2 volt is signal amplitude, and the signal has a frequency of how much? 10 kilohertz. Maybe your sound 10 kilohertz. 10 kilohertz is 800 kilohertz. Your carrier has high frequency. Okay, now describe for the carrier wave the variation of the amplitude and the frequency. After modulated, tell me what is the amplitude and what is the frequency variation. How much is going to vary? So this is FM. FM means this is FM. They're asking after modulated, this is a modulated signal FM. What is the final amplitude and what is the final amplitude and what is the what do you call signal? What is the signal? What is the amplitude and what is the frequency variation? They're asking. So what do you do? Amplitude of the modulated, is it change? Amplitude change? Amplitude doesn't change. FM amplitude doesn't change. Only the frequency change. So amplitude going to be, the amplitude remains 5 volt. Okay. The amplitude going to be exactly same as the carrier amplitude, which is 5 volt. Originally 5 volt, now also it's going to be 5 volt. Okay. Amplitude never changed. But frequency going to vary. Frequency going to vary how many times? Peak is 2 volt. So maximum going to be how much? Every 1 volt, frequency rise by 30 kilohertz. So 2 whole, frequency going to rise by how much? 30 times 2, 60 kilohertz. So when the amplitude reach 2 whole, the frequency going to rise by 60 kilohertz. So 800 original plus another 60 kilohertz become how much? It become 860 kilohertz. So the frequency at the peak here will be 860 kilohertz. At the center, zero amplitude will be 800 kilohertz, normal frequency of the carrier, and the lowest going to be 740 kilohertz. 740. So 860, 740, 860 back for one complete oscillation. So that's the answer finally. Therefore, the frequency fluctuate 740 to 860. 740, 860, 740 back. How many times it happens? It happens 10,000 times per second. Why 10,000 times? The frequency get 860, 740, 860, 740, 860 back. This happens same frequency as the signal. Signal how much? Is 10 kilohertz. It means the signal going up and down, up and down. How many times it go crest to crest? How many times it happens? It happens 10,000 times in a second. So the frequency also going to compress, increase, lesser, increase 10,000 times per second. This one description about FM. Okay. This could be about, can go like a 5 marks question, about 4 to 5 marks question. This one. Okay. So this is elaboration about FM. Okay, FM, frequency modulator. Any questions from here? Okay, I tell you here this topic is something new, but the questions are rigid. Rigid means what? The same thing will be repeated many times. Okay, so worth studying this topic because the questions rigid, cannot change a lot. I don't know how many times they ask about this pattern in your past year. Later you can view the past year, you can check how many times they ask this question. The same story. Carrier is this 5 volt, they give a different frequency. This is the signal. They'll ask you what is the final amplitude, what is how the frequency altered, how many times in a second. Okay. 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 So that's FM. Okay. AM, I'll get back later. Before we go to AM, now we need to know why you do modulation. Advantage of sending out modulated signal. Why you do modulation? So that many radio stations can now transmit signal at the same time in a particular area. Yes, each radio station is like a transmitter. So you can have many transmitters, many conversation can go around in the same area without interfering, without interference. So that's the main idea of modulation. Okay. How we do that? Each radio station is given a different carrier wave. Give a different carrier wave. The receiver is adjusted or tuned to receive a desired frequency. That's why I told you. A talking to B. Okay. When A talking to B, they given 800 kilohertz. When C talking to D, given maybe 820 kilohertz. So the phone will tune to that different frequency. Okay. So the aerial are transmitting the receiving the carrier frequency, so need to be long to cater the whole range of audible frequency. Yeah, another one thing. The aerial gets smaller. The aerial gets smaller. Okay. If you send a signal of 20 kilohertz, I told you what. 20 kilohertz of frequency, check the wavelength. The aerial must be quarter of that wavelength. So the aerial going to be long. Because radio wave frequency is higher than the sound wave, so radio wave will have a shorter aerial, so more convenient. Another side benefit, aerial is shorter. Okay, but main reason why you do modulation, to have many radio stations can transmit the signal at the same time without interfering. That's the main reason why you do modulation. Any questions? No questions. Okay. So this is the waveband of radio wave. We use the radio wave waveband from 3 to 30 gigahertz. 3 gigahertz is your radio wave. These are the frequency we divide, each and every one getting a different frequency. So, but AM normally transmitted in a long wave, medium wave, and short wave, low frequency. FM normally transmitted in high frequency, VHF and above. Okay. Why they make AM in a low frequency? Because AM low frequency means amplitude is wavelength is big or small. AM transmitted with low frequency. When frequency get low means wavelength get big, right? So AM has a big wavelength. Okay. FM has a smaller wavelength. Purposely they give like that. AM has a big wavelength transmitted in a low frequency band. So when a wavelength of AM is longer, what is the advantage of AM? Really can spread. Really can spread. So you definitely can get signal, but FM cannot spread, so the reception can be poorer in hilly places, especially. So FM won't be better coverage. AM is better coverage because wavelength is big, so really can spread. Okay, that's one advantage. AM. Okay, now we go for sidebands. Okay, this is sidebands are complex for FM. The sidebands in your syllabus only going to talk about AM only. AM. What is sidebands? Okay, the radio transmission involving putting an audio frequency information on a much higher frequency electromagnetic carrier wave. This process produces a frequency which are sum and difference of the carrier and information signal frequencies. These frequencies are called sidebands. See, when the signal added to the carrier like this, there are few different frequencies available become dominant. The frequency become in a range. It will become in a range. I need to show you with the IB later. So the frequency will become in a range. The center frequency is the carrier frequency. The frequency at the side will be the called sidebands. Okay, you see, radio transmission involving putting audio frequency information on a much higher frequency, electromagnetic wave. So the sound which is low frequency added to the high frequency electromagnetic wave. This process produces a frequency which are the sum and differences of the carrier information signal. So it means if the carrier is 800 kilohertz, if the carrier is 800 kilohertz, okay, it's 800 kilohertz. If the audio frequency is 20,000 hertz, 20 kilohertz, so the sideband will be plus 20, minus 20. The frequency change. So it's going to be 820 kilohertz. Here will be 780 kilohertz. And center is the carrier, 800 kilohertz. Okay. The highest frequency and the lowest frequency is called sidebands. These frequencies are called sidebands. Okay. So the difference between the two sidebands is the bandwidth. The difference between two sidebands, the width of these sidebands is called bandwidth. Bandwidth in telecommunication. What is bandwidth? It's defined as the range of frequency occupied by amplitude modulated waveform. What is bandwidth? Defined as the range of frequency occupied by the amplitude modulated waveform. Okay. So I'd like to show you something here. So we have a carrier of 1000 hertz, 1000 kilohertz. You have a signal which is 20 kilohertz. Okay. So how the waveband going to be? Okay, this actually can say power versus frequency, or power. Y-axis could be power, could be voltage, So center is the carrier. Center is always the carrier. Carrier, how much is the frequency? So center will be 1000 kilohertz. Okay, and the sidebands. Sidebands is what? Adding the signal frequency, which is 20 kilohertz. So the sidebands on top will be 1020 kilohertz, and the lowest will be minus the 20 kilohertz. So it's 1000. Sorry, this will be 980 kilohertz. 980 kilohertz. So this is called sidebands. These all are sidebands. What is the bandwidth? Bandwidth is the width of the sidebands. How much the bandwidth? In this case, bandwidth is 40 kilohertz. Bandwidth is 40 kilohertz. Remember, if the bandwidth is 40 kilohertz, the information you carry is only half of the bandwidth. Okay, the maximum frequency, okay, of the information is equals to half of the bandwidth. Remember, out of the bandwidth. So 20 kilohertz is your maximum frequency you can carry. Okay, this is the bandwidth. Okay, so you want to carry the 20 kilohertz information into a carrier of 1000 kilohertz. So the frequency required to air the AM signal must be from 980 kilohertz to 1020 kilohertz is the width. So if, let's say, another company B, another station, radio station B, this radio station A, radio station B want to use a carrier of 1010. You want to use 1010 kilohertz. Okay, 1010 kilohertz is the carrier. You want to use carrier 1010. The A uses 1000 kilohertz carrier. This one uses 1010 kilohertz carrier, and he want to send a signal of also 20 kilohertz. What happened to this frequency? Can you draw the frequency range for the second one? Second one B, for the case of B. The carrier is how much? Carrier will be 1010. The maximum sideband will be how much? 1030. Minimum will be how much? Minimum will be 900. Minimum will be how much? Minimum will be 990, right? Maximum is 1030. Yeah, 1030. Minimum will be how much? Minus 20. 990. Yeah, 990 kilohertz. Okay. Can this company B add signals with A? You can't. Why? Overlapping happen. Okay. Although this is 1020, overlapping happen. So you want to add this signal B together with A. What carrier you must use? You can use carrier, maybe you can use 120. You can use 120. If you use a carrier of 120, so center will be 120. You can't use 120. Sorry, can't use 120. Use 140. You have to use 140. If you use 140 for the carrier, the upper sideband will be how much? 160. Lower sideband how much? Will be 120. Just nice. You see, the upper sideband for the first one is 120. Lower sideband for the second one is 120. So not really overlap, just the border. So you can send another signal. So what I'm trying to say, you can't use the frequency in that sidebands. The sidebands is 980 to 1020 for the first signal. The second signal you want to transmit, the bandwidth entirely should not overlap with the first one. If overlaps, interference will happen. Okay.
So that means that two radio companies must have a information signal that makes an FM or AM that is not going to overlap with another radio company's FM or
Yeah. Yeah. Correct. So the Malaysia government will delegate the frequency. Okay. You know, recently the 5G, I think the contract is given to which company to use that waveband, the frequency band.
with the
So
company.
I don't know which company. I forgot. 5G, Maxis. I'm not sure. So the frequency given, the frequency range given to that company now. Let's say Maxis, given to Maxis. So other companies can't use that frequency. Okay. Let's say Maxis given a range of, let's say Maxis given a frequency of, let's say I'm just saying, let's say given from 1000 kilohertz, it gives 1000 kilohertz to, let's say, 100,000 kilohertz. Okay, I clear this. Very massive. Let's say Maxis, the government give, it can use 1000 kilohertz to 100,000 kilohertz. Okay, 100,000 kilohertz. Okay, so Maxis decide want to send signal in AM. Okay, want to send signal in AM. So, and you want to send every AM signal, you want to use a bandwidth of 40 kilohertz. You want to use the bandwidth of 40 kilohertz. So, from 1000 kilohertz, 40 kilohertz of width must be used for one signal, one radio station. How many radio stations you can have? The Maxis can have. So how do you do? How many? Because the frequency given to them 1000 to 100,000.
Oh.
So what do you do? So the difference is right. Difference how much? 100,000 minus 1,000 is 99,000, right? 99,000 divided by 40. This is the number of radio stations. Or in other words, this is the number of conversation. Okay, conversation can happen at a one particular time. If it's a phone call also same. Phone call also, you're, let's say, A talking to B. So Maxis give 1,000 to 1,040 as the frequency for you to use lah. At that, you are calling at 8 o'clock in the morning, 8 a.m. Okay, so you making a call. So Maxis, you are the first caller lah. So Maxis give 1,000 to 1,040 for you. Okay, let's say 8 o'clock. Many other people also want to call. So how many people can call at 8 o'clock? So depend to how many can fit in here. Okay, so 99,000 divided by 40, how much you get roughly? Okay. So I just put a number lah. Let's say I give a number. Let's say the number of slot available. Let's say 20,000 signals can be sent at a time. So at 8 o'clock in the morning, only 20,000 people can use the Maxis phone line. If let's say another guy want to 20,001, the last 20,001, this person tried to call, what you will get? Line will be busy. Line is busy. Why? The Maxis can't afford to allocate you a frequency because all occupied. So line is busy. Okay. So when it can allocate you the frequency, when one conversation is done lah. When A done with the B and this slot is empty, then suddenly you make a call, you will get this frequency. So you got an idea? So what I'm trying to say here is the bandwidth. Let's say now tell me that Maxis has 1,000 to 100,000 kilohertz of frequency range, but Maxis want to send a signal in FM. You want to send a signal in FM. Okay, if FM means the bandwidth is huge, bandwidth of FM is greater than AM actually. A bandwidth of FM can send videos and everything. Normally FM maybe I think 270 kilohertz if I'm not mistaken, FM bandwidth. Okay, so if a Maxis send FM, What is the plus? What is the minus? What is the minus? What if you want to send the FM signal 270? You make a call. Your signal is transmitted through FM. Actually, now your signal is at FM, not AM. FM. So AM compared to FM, what's the problem the Maxi is going to face? The number of users is going to be less or more? Number of users. Because bandwidth is big, Bandwidth big means now not 40 used by one conversation, 270 used by one conversation. So number of users is going to be decrease or increase? Will decrease. The number of users will be decrease. But the signal is quality. Signal is quality, but number of users will be decreased. So that is one price to pay. If you want a quality signal, bandwidth is going to be increased. When bandwidth increased, the number of signals carried at a one particular time will drop. So number of users is going to drop. If the company is a very, very rich company, like Maxis, let's say it's a very rich company, they can request a big frequency of allocation from the government. They have to pay more. Understand? Okay. So this the fighting between one company to another company now. Which frequency they going to possess? Okay. So yeah. So that's about sidebands and bandwidth. Okay. Bandwidth determines number of signals can be carried in a certain waveband. Okay. Sidebands get wider if the information if greater bandwidth means greater information you can carry. Okay. Like sending your signal with 5 megahertz. Okay. What is you have two waveband, right, in your houses. If you go use Wi-Fi, 5 megahertz and 2.4 megahertz. 2.4 megahertz, right? 5 megahertz, 2.4 megahertz. Okay. Which is faster? 5 megahertz faster, right? Okay. For example, you see, if I click here, so you see, sorry, not 5 megahertz, 5 gigahertz, 5 gigahertz and 2.4 gigahertz. So normally you have two lines. 5 gigahertz is 5 gigahertz to 2.4 gigahertz, which is more faster. 5 gigahertz, right? Carries more information. Why 5 gigahertz greater? Because greater bandwidth. 5 gigahertz has a greater bandwidth, so it can carry lots of information. 2.4 gigahertz is less bandwidth. Okay, less bandwidth. Okay, but what is the benefit of 2.4 gigahertz? Anyone? What is the benefit of 2.4 gigahertz compared to 5 gigahertz? Anybody? Can reach further. Yeah, it can reach further. Why it can reach further? Because its wavelength is longer than 5 gigahertz, right? V equals to f lambda 1. When frequency is higher, wavelength gets shorter. Speed is same. So when wavelength so 2.4 is a huge wavelength, so it can spread, so it can reach us further distance. That's the use of 2.4. You want to go further distance, use 2.4. You want to get faster, 5 gigahertz, but shorter distance. Okay, so that's about bandwidth. Okay, 5 gigahertz, big bandwidth. So it can carry lots of information. How many information can carry? Half of the bandwidth, normally. Half of the bandwidth. So the difference between the two sidebands is the bandwidth. Bandwidth is defined as the range of frequency occupied by the amplitude modulated waveform. Because of the existence of the sidebands, the frequency range of the bandwidth necessary for radio transmission depends on this range modulation frequency. Okay, for one example, you want to transmit with the AM, the signal frequency is 200 kilohertz. This is the signal frequency. The transmitter is broadcasting a program music with a maximum frequency of 4.5 kilohertz. Broadcasting AM signal frequency 200 kilohertz. Or this is the carrier, 200 kilohertz. The signal is 4.5 kilohertz. Determine the AM signal, the wavelength. The wavelength of the carrier is 3 divided by the frequency, 200 times 10 power 3. So 1500 meter is the wavelength. This is the wavelength of the carrier. Bandwidth will be how much? because the signal is 4.5 kilohertz. So the bandwidth will be 2 times 4.5, 9 kilohertz. Okay, the bandwidth is 9 kilohertz. That means what is the frequency range you must use? So for this frequency range, the carrier is 200. The sidebands will be plus 4.5. So 204.5. The low bandwidth will be what? Minus 4.5. Minus 4.5. So it's become what? 195.5 kilohertz. So 195 to 204. 195.5 to 204.5 kilohertz actually used up by this signal. Any signal cannot take this frequency. This frequency has been occupied. From 195.5 to 204.5 frequency has been occupied by this signal. Other signals cannot overlap with this. Okay. So yeah. So this is bandwidth. Bandwidth is 9 kilohertz. Bandwidth is actually half of the signal frequency. The signal is 4.5 kilohertz. Bandwidth have to be double for AM. Any questions? No questions, Okay. Number of radio stations. AM radio station broadcast in megawatts waveband. Okay. Medium wave, not megawatts. Medium wave waveband, which occupies a frequency of 300 kilohertz to 3 megahertz. So tell me, how many radio station can transmit between these two signals? The AM bandwidth is normally 9 kilohertz. It's only 9 kilohertz. AM only to transfer sound, no videos, just sound. Conversation only, 9 kilohertz. So how many radio station could share this medium wave? So 300 to 3000, how much is the range? 3000 minus 300 divided by 9. One bandwidth is 9. So 300 radio stations, 300 signals can be transmitted at the same time. Only 300 radio stations. Okay, this waveband. If this waveband you want to use of FM, I think, so how do you do? You divide by, not 9, you divide by 270. 270 kilohertz is the waveband of FM normally. So the number of signals is going to be lesser, but more quality. A choice is to the company. They want to use AM or FM. Do they want to transmit only sound, but they want to be cheaper? Don't want to have multiple amplifier, so cheaper. They go for AM. If they want a quality signal, but they need to compromise with the number of users, then you have to go for FM. I think now all radio signals is FM. More quality. Quality. Any questions? Okay, guys. So one example. When you see this graph, power versus frequency with 3 lines, this is the power line. Okay, the power line of the carrier will be highest. The power line of the sidebands will be shorter. How they got this different? This is actually the amplitude. How they got the amplitude is half. It's actually a trigonometric derivation. It's a little complex. Maybe next class I show you from the IB book. You see, the carrier has a formula x equals to x naught sine omega t. The signal also is sinusoidal. Maybe y equals to y naught sine omega t. Okay. The signal displacement has been added to the carrier formula now. So the formula turned to become x equals to x naught y naught sine omega t bracket another sine omega t now. It's a complex mathematical trigo expansion. X naught plus y naught sine omega t close bracket sine omega t again. So this, if they derive, finally they will get few amplitudes. they will get this A naught, they will get these two amplitudes. The two amplitudes they got at the side is normally A over 2, half, the derivation. Okay, maybe next class I show you from the IB book. IB book show the derivation, but you don't need to know for your syllabus. Okay, so for AM, when you draw, make sure sideband amplitude is shorter than the carrier. Carrier is longer. Okay. So from this graph, tell me what type of modulation it is. So this is your AM modulation. Okay. A levels only investigated the sidebands of AM only. FM is quite complex. Okay. They never show. The component of the frequency 50 is what? 50 is the carrier wave. 50 is the carrier frequency. 50 is the carrier frequency. The component of the frequency of 45 and 55 is what? That's the sidebands. Sidebands. That's sidebands of the signal. Okay. And we state the bandwidth of the radio signal. Bandwidth of radio signal 55 minus 45 lah. So is 10 kilohertz. It's bandwidth. Okay. Next. On the axis 10.2, sketch a graph to show the variation of time t of the signal voltage 10.1. How the signal voltage is going to vary? This is 50 kilohertz, this is 55 kilohertz. See how the voltage is going to vary with time. This is you need to draw the you need to draw the AM amplitude modulation like this, getting bigger and smaller like this. This is the pattern of AM curve. Okay, you have to draw here. Okay, but how much this short period? This is a long period. Okay, from here to here, long period. Sorry, let me. Okay, this is your signal. This is your carrier. And finally, these two add up, become what? Add up like this, getting bigger and getting smaller, getting bigger. Okay. So this pattern is over here, correct? So the smaller period is the period of the carrier. Okay. The peak to peak and the peak to peak, this period is going to lead to the period of the signal. Okay. So remember, so here to draw this graph, what is the frequency of the signal? Frequency of the signal is 5 kilohertz. 5 kilohertz. 5 kilohertz. What is the period? 5 kilohertz. 5 kilohertz is for the signal. Okay. What's the period? Period is 1 over 5,000. You get the period. Okay. Then you take the carrier. Carrier, what is the frequency? 1 over, what is the period of the carrier? Carrier is 1 over 50,000. You get the period of the carrier. Okay. So the sketch the general shape. So they found that the carrier is 20 microsecond period, and the signal is 200 microsecond. It means what? 20 microsecond. 20 microsecond is the carrier. So the length goes up, come down, goes up, increases up to it become 100. Okay. At 100, you reach the top. 100 you will reach the top. Okay. Oh, suddenly this is missing. Then after that, get shorter again. Sorry, get shorter again. Get shorter up to 200. This is like one complete period of a signal. This is like a negative sine graph. This is negative sine graph. This is like one complete period. This is one complete period. It's one sine graph. Okay, class. I think I'm rushing. Okay, this part maybe I recall it next class. Okay, for time being, understand what we taught about AM and FM. Okay. Next class, I will redraw this back because I got another class to go. Any questions? Okay, class. So I stop here. The next class, I will draw the graph back because rushing because I've got another one class to go. Okay, I see you then tomorrow. Any questions? No questions. Okay, see you then. Bye.